Raise your hand if you have something for this part.
Final distance minus his starting distance.
Okay, I took this exact question out of the calculus, my math lab homework from when I taught calc. Okay, this is totally something you will look at in calculus, because that's what a lot of calculus is about. Rate of change, average speed is a rate of change. How fast is your distance changing with respect to time? How's the distance you traveled in miles changing with respect to time, hours? So the bicyclist starts at home, right, and starts pedaling. So as time goes on, their distance from home is getting farther, right? So the miles are increasing. Do you agree?
Yep.
Miles are increasing over time. Okay? So, but is the cyclist going the same speed the entire time? No. What would it look like if the cyclist went at constant speed the entire time? It would be a line, wouldn't it? Okay? Right? Constant speed. So the speed, so it's speeding up, it's slowing down, speeding up, it meaning the bike, not the person. Okay, I keep saying it, I don't know why. All right, so the speed's changing. So what I want to know is what was the average speed between 1 and 3, because 1 and 4. It's kept speeding up, slowing down, right? Stop at a stop sign, et cetera, et cetera. Okay? So then how do we find the average speed? What's the distance that it traveled between 1 and 4? Right? At 4 o'clock, it was 28 miles from home, the bike. At 1 o'clock, the bicyclist was 10 miles from home. So between 10 and 28 miles, that difference is 18 miles. Okay? Time, 3 hours. Okay? So 6 miles per hour. Okay? Now, why did I put this line through here? Because that's the whole point of this section. Okay? So I'm talking about on the interval from 1 to 4. Okay? The average speed on the interval from 1 to 4 is basically the same thing as the slope of this line through those 2 points, isn't it? Slope of the line, change in y over change in x. Isn't that slope? Right? Here's your y, here's your y2, here's your x2, here's your y1, here's your x1. Remember that? Slope, change in y over change in x. So the idea is the slope of this line is 6, which is the average speed or average rate of change of that function, right? That's being modeled, distance function, position function, we call it in calculus. The slope of that line is the same as the average rate of change of that function. Okay? Now, what do we call this line? We call it a secant line. Secant meaning, remember secant means cut? So a secant line is a line that intersects a curve at 2 places. Secant, okay? If I asked in calculus, you'll talk about average rate of change. How do you find the average rate of change of a function over a certain interval? Okay? What we really want to know is at 1:30, how fast was the cyclist traveling? At that instant in time, how fast was the bicyclist traveling? That's called the instantaneous rate of change, and that is actually, well, that wasn't real great. That is actually the slope of the tangent line. So a tangent line intersects a curve at 1 place. I can't remember if we talked about that or not in here. Okay? This is a secant line. 2 places. Okay? So you'll do something just like this in calculus, introducing and getting comfortable with the terminology and the slope of which kind of lines calculates what. Okay, so I want you to see it. Instead of just saying, here's the difference quotient, find it. I want it to make sense. Plus, then when you see it again in calculus, you can tie it together to things that, connections of things you've already seen. Okay? So, the big point here is that the average rate of change of a function on an interval is the slope of the secant line through those 2 points, meaning the points that occur at the beginning and the end of the interval, right? If it's on the interval from A to B, then we know that it's the slope of the line through these 2 points. So, how do you find slope of a line? Change in y over change in x. Brian brought this up. Thanks for reminding me. So we could say that's delta y over delta x. Do you remember change means delta? Okay. So it's basically, as you already know, y2 minus y1 over x2 minus x1, or who cares about the subscripts? It doesn't matter as long as you're consistent. Okay? So how do we find the slope of the line through these 2 points? Subtract the y coordinates. So it's the end point of the interval minus the initial point of the interval. So it's f of b minus f of a. So it's your y values or your function values. Zach, you referred to this as f of b, what did you say?
It is final position minus initial position.
Final position minus initial position. Very nice. I heard you say it perfectly. Thank you. Yeah, final position. So in our bicyclist, this is where it was at the end of the interval at 4 o'clock. Perfect. And this is final time minus initial time. Okay? You're going to do this a lot in calculus in the beginning. Okay? So get this in your head. Average rate of change, slope of the secant line between the initial and the final position. If you're talking about that kind of change, if that's what your function is. Okay? So what we want to do is we're going to go to just some different notations, same idea. Okay? So this is what we call the difference quotient. You're going to use this a lot in calculus in the beginning to develop a really important concept called a derivative. Okay? So we're just using new notation. So now, instead of saying A and B, I don't want to use specific values. I want something that will calculate the average rate of change no matter what the interval is. If it's this interval or little intervals, okay? I don't want to have a specific in A and B in every time because that's a lot of work, okay? So we're going to change our notation and say, if I know the x value, the beginning of my interval, okay, and I know how wide my interval is, so if x is here, then I add some value h, then my final position would be x plus h, right, would be there, or my final time, whatever you call it, okay? So we're going to use this notation h instead of a and b, okay? So that means this point P has coordinates x, f of x, because this is my function f. So whatever the x coordinate is, you plug it in to get the function value as the y coordinate. And this has an x coordinate of x plus h, and the function value would be the y value if we plug that x plus h value in. So it's the same thing as the a and b, it's just different notation. Okay. So this is kind of the notation that we use in calculus. We'll do something like this. Well, what letter do we use to represent slope? M. And then we use a little subscript like this, m/secant, slope of the secant line. Just for fun if you want to see it. Okay, so the slope of the secant line then can be found, or basically I can calculate the slope of this secant line, which will give me the average rate of change of this function on this interval x to x plus h. So if I apply the slope formula, subtract the y coordinates. So f of x plus h minus f of x. And let's go downhill. And then subtract the x coordinates. X plus h minus h. So I'm subtracting the y's on top, subtracting the x's on bottom. Okay, simplify that. We can simplify the bottom, can't we? The denominator. So top stays the same, can't do anything. The bottom becomes x. Okay? So this expression will calculate the slope of the secant line on an interval from x to x plus h. Okay, there is one restriction. Oops, what happened? Where'd I get? What? Debbie, what's going on here? That should be x, shouldn't it? I was gonna write h can't be 0. I'm like, where'd h go? My bad. X plus h minus x, which is h. And then h cannot be 0. Okay? So this thing right here is called the difference quotient. I can calculate the difference quotient for any function. Some of them it's really tricky, so we only do certain types of functions, even in calculus, just to get the idea across. All right? It's called the difference quotient. It calculates the slope of the secant line or the average rate of change of a function on an interval. Okay, granted, h can't be 0. In calculus, we let h get close to 0, but we never let it be exactly 0. Okay? And we use this to come up with the slope of the tangent line or the instantaneous rate of change. So here, we're just practicing this algebra. That's all we're doing here, getting you practice so you can do the calculus stuff, and the algebra will be like a breeze, right? Okay, so whoever said comfort zone, what we're doing next is comfort zone. It's basic algebra, okay? So some of you might really like it. All right, so we're gonna evaluate, or find, I should say not evaluate, we're gonna find the difference quotient for given functions. We are only gonna do polynomial functions and rational functions. In calculus you do radical functions, square roots, but we do not. Okay, now there is a different way of doing this, okay, but I am doing it this way just so I can talk to you about how you're entering it in my math lab. We can then do it the other way, but I want to give you an idea, okay? So, difference quotient, okay? What I recommend you do is write it down each time you're going to use it so that you learn it. You will have to know the difference quotient on the exam. Okay? On this exam. All right? So write it down. Okay? The difference quotient is basically you set it up and then you simplify it. That's what it is. What does this setup mean? It's kind of a 3-step process. So we're going to do each step individually just so we can talk about my math lab. I'm okay with, I like it and I don't like it the way my math lab has you do it. It's nice because they make you enter the in-between steps, so if you made a mistake, you're not like to the very end and then you're going, oh my God, where is it? Okay, so you can catch a mistake early on, which is a good thing. But it's a lot of extra writing if you're doing it this way. So I don't care how you do it on your paper as long as you can get to the answer. And you know what to put in my math lab. Okay? All right, so here's my function. Linear function, f of x is negative 2x plus 3. Okay, so first thing we would do if we were setting up this quotient is we would find f of x plus h. Okay, that's basic college algebra. You plugged all kinds of stuff into functions. That's all we're doing here. We're plugging in x plus h into the function in place of x. And we're simplifying it. Okay, so this is our step 1. All right? So, if you love algebra, can you do this? Pretty basic stuff, right? So it's -2 times x plus h plus 3. Okay. All right. And then simplify it. Okay. So this is f of x plus h simplified, so to speak, right? Okay. My Math Lab will give you these 3 prompts just as I did. So they're going to want you to enter this in My Math Lab. Then you know if you did it wrong, fix it. Because you're going to have to use that to continue on. Okay? So that is the nice thing about having to enter them separately. All right? So step 2 then, what does this mean? Well, once we plug x plus h in, then we are going to subtract f of x. What does that mean, subtract f of x?
2x plus 3.
Yeah, f of x is the original function. So we take what we got from here, from f of x plus h, and we subtract from that the original function. So I'm going to subtract my original function, which is -2x plus 3. Notice how I put it in parentheses. If there's more than one term, you have to make sure you subtract every term. All right, so you're going to have to distribute that negative sign through, which means that becomes plus 2x and minus 3. Whoops. And then combine like terms. So when I combine like terms, these are opposites, add up to be 0. These are opposites, add up to be 0. So I'm left with -2h. Okay, so if I was putting it in this quotient, that's what the top would have simplified to. If I just set it up in the quotient and then simplified, which is totally fine. Okay? So this is what My Math Lab wants you to enter then. They want you to enter what you got after you subtracted and simplified. Okay? All right, last step, third step is then to divide by h. So if you were setting it up, you'd put those top things in, and then you'd put it over h, and then you'd simplify it if you want to do it all in one swoop, which is what you will definitely do in calculus. And we can do that too if we want on Thursday. We'll do another one in that way. All right, so what do we have for the top? We have -2h, and we're dividing that by h. So we end up with -2. So we're saying the difference quotient evaluates, simplifies to -2. Okay, so then you would enter this last in My Math Lab.
What is that value representing?
Good question. What does that value represent? Okay.
Oh, yeah.
The difference quotient calculates the
Slope.
slope of the secant line through what points?
X and X plus H.
Yeah, x and x plus h. Or any 2 points, basically, depending upon what x is and h is. I don't have any x and h, so it doesn't matter. But yes, it would depend on the x's and h's, yes. Through any 2 points. So think about this original function. Was f of x is -2x plus 3, right? Okay, it's a line, graph it. Y-intercept is 3. It's got a slope of -2, here it is. Okay? So if I choose any 2 points on that line, here's P, here's Q, draw the line that goes through those 2 points, which happens to be the same line, isn't it? Okay, so what's the slope of my original line? The slope is 2. What's the slope of the secant line? Or sorry, -2, my bad. -2. So if your function's linear, then the average rate of change or slope of the secant line is always the slope of the function. Isn't slope a rate of change? Okay. Now, is it always going to be a number? No. It's going to be dependent upon x and that distance h. So our difference quotient could involve x's and h's as well. Okay? Questions? How many of you have seen this? Some people probably have. We don't do it in college algebra anymore here, so you may have seen it somewhere else. Or if you took it, I don't know how long ago we stopped doing it, but people in college algebra shouldn't be tortured with this because this is really for calculus. So we took it out. Okay, all right, let's set this guy up. So how many people are like, oh, I love algebra, comfort zone? Okay, somewhat? Okay. All right. This is more algebra. All right, here's my function. It's quadratic. It's a parabola. Okay, opens up. I don't know where the vertex is. So let's come up with the difference quotient, which would calculate the slope of the secant line through any 2 points. Okay? All right, so what are we going to do? Everywhere we see an x, we're putting x plus h. Let me scooch up a tad. Okay, step 1. All right, here we go. So replace the x and simplify. Okay, you're not just adding h at the end, you're replacing x with x plus h. And then simplify, follow the order of operations. Order of operations says do what first? Exponents. Simplify inside parentheses, can't. Exponents, got it, right here. Square that binomial. How many terms should you end up with when you square a binomial? Three. It's a trinomial. It's a perfect square trinomial. So how do you square it? If you need to FOIL or distribute, or you can always use the shortcut, a squared, whoopsie, a plus b squared is a squared plus 2ab plus b squared, right? You can use the shortcut, or you can just distribute and combine like terms. I don't care. But it's not x squared plus h squared. You do not distribute squaring. Every time you do that, you have to pay me $5. Okay? I'm working on my retirement fund. My travel fund. So you end up with a perfect square trinomial. Okay? Trinomial when you square a binomial. All right, then, okay, so we did exponents. Next thing is multiplication, division from left to right. We've got multiplication. Distribute. Combine like terms. None? All right, that's simplified. Oh, so yeah, this is where it gets like the bummer. So then you enter that in my math lab.
Cool.
What?
my favorite part of math lab.
What, entering it?
Oh, yeah.
Oh, you like it? I'm so slow at it.
I'm being so sarcastic.
Oh,
No, I-
you just wait till you get calculus. Ay, 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 that kills me. I can't, even just practicing, I go, oh my gosh, I can't, this would make me crazy. But I wasn't raised typing into a computer either. We didn't have those when I was growing up. We had stone tablets, chiseled out our work. All right, so what are you gonna do now?
Subtract the original function.
So from that, you're gonna subtract. On your paper, you don't have to rewrite it. I need to do it for my notes, right? You can just subtract it, okay? But I'm doing it for up here. I don't expect you to do all this extra writing. Ugh. Painful, because then you copy stuff down wrong. You meaning me. Whew, that was painful. Minus the original function. And then distribute.
Well, I mean, you have to divide it out anyways. I don't know what
No, I think you're right. It doesn't matter.
Well, I'm sure my math lab might not take it if it's not like factored properly. So I don't know.
Yeah, let's see
And then combine like terms.
6xh plus 3h squared plus 5h. Can you take an h out of that, though?
Yeah, that's next step.
Okay, yeah. It's a lot.
So this is what the top, if you had the quotient, that's what your top would simplify to. Okay? We good? Did I mess up? I messed up my other class. I had the wrong sign, which made me have to go all the way back and redo a couple of spots. Okay. All right. Now, the grand finale, step 3. All we have to do is take what we got from the top and divide by h. So we're taking 6xh plus 3h squared plus 5h and divided by h. And how you divide that is up to you. There's 2 different ways you could do it. As long as you do it legally, I don't care, and know when you, it's good to do it that way and not. So, doesn't matter to me. Two schools of thought here. Simplifying a rational expression would be factoring the numerator and denominator, and then dividing out common factor. That's probably what you'll do more often than the other method, okay, to be honest. So it comes out to be 6x plus 3h plus 5. Or, especially when I see that they all have a factor of h, right? And there's only one term here, right? I can take everything on top and divide by h. So that here it works nicely. If one of these didn't have an h, I wouldn't do that. Okay? But it depends what you need it for. So comes out the same in the end. So notice how now my difference quotient involves x's and h's. So if we were, what that means is, I don't know where the parabola is, so I can't draw my x and y axis. I should have done it so I knew, but I don't. Okay, so that means whatever 2 points you choose, if I choose this point as my P and this point as my Q, and I want to find the slope of the tangent line through that point, then I would need to know this x, right? And then I would need to know this distance h to the other one, which you don't actually really plug those things in, but it's a concept. The idea is that you can get this expression that would work for any 2 points, any x value for your beginning of your interval. Okay? And then in calculus, you do something with that expression with h. You let h go to 0. Cool? Questions? So bring that page back Thursday and we'll do another rational function one, okay? All right. My last class I thought it was Thursday. And I said, oh, see you next week. See you Thursday.
Yeah.
I can never leave it. You know what?
Have a good afternoon.